So, good morning. Welcome to another edition of the Tiny Lab Talks. And today we are going to speak about, well, it's a question. What about our littoral in 40 years? These Tiny Lab Talks are briefly informal talks between researchers invited by the University of Aveiro and researchers from the University of Aveiro itself, through the American Corner program, on topics such as technologies, innovation, research and culture. And these conversations usually they happen here at this US American Corner where we are, with the support of the US Embassy in Portugal. So I give a warm welcome to both of you to be here, and Daniel Cox and Carlos Coelho. Daniel Cox is, he has made a PhD in civil engineering at the University of Delaware, and currently is a professor in civil engineering department in Oregon State University in the States. His research focuses on community resilience and to coastal hazards, including tsunami and hurricane surge and waves inundation in the built and natural environments. He conducts research on tsunami and wave impacts on near coast structures, tsunami evacuation and life safety, sediment transport and erosion, and nature-based solution for the coastal hazards mitigation. And Carlos Coelho is professor here at the University of Aveiro. He has a PhD in civil engineering here at the university, and in the subject of coastal engineering. He is the president of the Innovation Board of the Portuguese Association, we call it APRH in Portugal, and he is one of the Portuguese delegates at PIANC. His research is published in several international and national journals, also in conference proceeding papers. He has supervised several PhD and master theses, also being the PI of several projects. He was a member of the commission that followed the littoral working group in 2014 or 15, and he also collaborates and consultancy work developing coastal management plans and sediment dynamics and hydrologic studies. And myself, my background is in physical oceanography on the University of Lisbon, and then I made the PhD here in Aveiro University. My research works are mainly related with sediment transport and morphodynamics of coastal systems, collection of field data, and development and application of numerical models. So, giving this introduction, we will start to make some questions. For both of you. The first one is, can you tell us a little bit about your career paths and key moments? And if you look back, how did you want to become a coastal engineering researcher? And it was by accident, it was a question of opportunity, or it was something that you always thought about it? And after that, what was the motivation to continue to do research? Mm-hmm. So, I don't know if you can start.
Sure, I'd be happy to start. I would say maybe happy accident, my career path. I think a love of science and physics, but ultimately wanting to look for some solution or some way to solve a particular problem. And growing up near the coast, I think, okay, here's really interesting natural problems, but then also because there's so many people on the coast, we're creating other types of problems. And I think that just became a really interesting and fascinating way to try to solve these problems, combining lots of different pieces together. So I think that's always been kind of a fascination. What piece do we need to bring in to solve problems with beach erosion or tsunamis or hurricanes?
Yeah.
Well, for me, I think it was a little bit an accident. So when I finished my degree in civil engineer, I didn't know what to do, and I applied for a master in civil engineering. At the same time, I managed to start to work in a company designing structures. Then, when I finished my master, I was invited to replace one professor at Porto University that was going out for the sabbatical period. So during 1 year, I was replacing that professor and at the same time working at the designing company. I enjoyed the experience of teaching in the university, and so just when I finished that year replacing that professor, there was an opening here at the Aveiro University. So I applied, and so I started to work at the university, and they asked me to change a little bit of my scope of work because I was working at designing structures. And so here they said to explore the hydraulics and the maritime hydraulics. And I'm happy with that because I think it's a very challenging area. And so I'm happy to be here and to, last more than 20 years working on these topics. But I came here a little bit by accident.
Yeah, that's...
It was not planned.
Okay, thank you. And the theme of this conversation is this question that what about our littoral in 40 years? And so this is a question. And in your view, what are the most important processes that will impact the coastal zone? And therefore we should be aware. And sea level rise and changes in the wave climate, and also the extreme events, storm surges, and the sediment budget, the input from rivers. What should we? Well, I think it depends on the place where you are, of course. But in a general, we can suppose in a general way, what are the most important things that we should look at it? So it's. Of course,
I can start.
40 years horizons.
Sure, I think maybe you mentioned a number of natural processes, so climate change, sea level rise, wave climate. I think these are all important aspects. And I think we can also add kind of the human element too, like how will we as a society change on the coast? Are we planning to live near the coast, to economic activity, tourism, recreation? I think all of these things have to be added in as well. So how do we plan to coexist with the coast? So those are, I think, very important questions that have to be added to this, the question of natural processes. So natural processes and the human processes coming together at the coast. That's my view.
As you said, I think that the most important factors depend on the site, so on the location. For instance, here at the central region of Portugal, one big issue is the sediment budget and the sediment deficit. So we have a lower amount of sediments than we need to feed the littoral drift. Maybe during the next 40 years, with the evolution of the shoreline to a new equilibrium position, the other factors can be more important than if we reach some new position of equilibrium, maybe the sea level rise or the climate change effects on storms or on wave direction, for instance, can be more important in the future. Nowadays, for instance, in this region, I would say that the sediment deficit is very important. So how will be in the next 40 years, I don't know. I think we may explore several different options, considering the human occupation on the shoreline, if we should protect, relocate, trying to mitigate the sediment DFis with the artificial nourishments of sediments. So we have all this as ways to make interventions in the shoreline and the littoral.
Yeah, this is a little bit related to my next question, because picking up your words, how to mitigate the effects of coastal erosion, because we are now doing things, but what is the trend for what is the trend for the future? Because each nourishments are these soft measurements are also or not combined with the hard constructions measurements. There are other things like vegetation and things that are being equated now to the future. So I would like to see what is your view for this, how to mitigate the coastal erosion in the future.
Yeah, great question. I think some of the approaches, for example, are the regional sediment management. So some of the things you're describing, if we have to dredge the harbor, what to do with the dredged sediments. Are there places that we can put them near shore or on the beach directly? So I think kind of a holistic view of the regional sediment management is key. And I think the point that you brought up as well, these looking for natural solutions or nature-based solutions, trying to incorporate these in some of our designs. So examples would be using vegetation in some locations that can reduce the wave energy, but it's also very site-specific. So if we have very high energy, maybe not a good idea, but if it's an embayment, maybe we can use some vegetation or oyster reefs or something that what we would call in the U.S. living shorelines to protect some of the issues of coastal erosion.
Have you some couple of examples in the west coast of the states that were already implemented such measurements?
It's a great question, because if you go around the United States, some areas have higher energy, and so some of the solutions don't work. Where I'm from in Oregon, it's extremely high energy, and so one of the solutions that we're looking at is called a dynamic revetment. So these are, instead of large rocks, just using smaller cobble. And the idea is that the cobble will move around, so it's dynamic, but ultimately it doesn't move so far that it can still protect the shoreline. So in our latitude, we have lots of these naturally occurring cobble as well. And so when people go to the beach, they recognize it, and it's more acceptable to use the cobble. But still, some research has to be done on effectiveness. Do we have a renourishment cycle? Do we not create any other problems anywhere else on the littoral itself? But yeah, in Oregon, we're spending a lot of time now on trying to understand dynamic revetments, cobble revetments.
Interesting. Well, my typical answer to that question, considering this region, I would say that everything that we can do to reduce the sediment DFis is good. So if we can keep the sediments in the system, for the coastal system, for instance, when we do dredging, we need to put the sediments down-drift. If we can keep the sediments in the dune system, if we can protect the dunes, making the people go to the beach by the adequate pathways, we should do that. And I think on that point, we are already doing this. But we have still big deficit of sediments, and this will continue to happen. And so then I usually say three big options to think about the management of the coastal areas that are, well, if the problem is the sediment deficit, one option can be bring sediments from out of the system to the coastal system. Getting the sand from offshore, of course knowing that we have an energetic wave climate that will transport sediments that will deposit there to downdrift, and so this is requiring a frequent intervention, with, of course, costs related with that. But we are keeping the sand in the system, so trying to keep it more natural and attractive. Other options are to reduce the consequences of the coastal erosion, trying to protect our goods and infrastructures, for instance, with the coastal structures. And here I'm not distinguish the kind of coastal structure. In general, coastal structures do not add sediments to the system, so we can protect some area with groins or revetments or detached breakwaters, protecting that area, but we are transferring the problem of the sediments deficit to another area that probably is worth less than the area that we are trying to protect. So protection can be an option. Other option can be relocation of our goods or infrastructures that are exposed to the erosion process. So we can, it's always complex because it has a social impact too. But I think these are the three main options: bring sediments to the system, protect the infrastructures, or relocate. And we can think about all of them. We can think about combining all part of one or two of this. For instance, we can do nourishments, but at the same time some structure to try to keep the sediments in the area that we make the deposition. So I would say these are the options, and with this we are getting time to have another solutions. For instance, this kind of research that Daniel was saying, or others, improving the material performance or the interventions performance. So I think this is the way.
Okay. So on the talk that yesterday, on the round table, you have presented a lot of your work concerning the tsunami, and these on the impacts that tsunamis have on the coastal environment. Can you talk about a little bit about this, because this is very important also for us here in Portugal.
Sure.
And can you talk what is the focus that you have on modeling or on a forecast, evacuation times? How can you manage that?
Yeah, great question. Yeah, the number one question in the Pacific Northwest is on life safety. So that's still at the top priority, is to make sure that people are safe if we have a tsunami. We have lots of tourism on the coast as well, similar to Portugal, and then a lot of local people. So it's, I think, a question of education and coming up with what are the best options for people when they're on the coast, trying to understand what the risk is and how to get people to safety. That's number one. And we do a lot of that work through computer simulation. So trying to visualize what the event looks like, how much time they have to respond, what's the best route to go. And so far that work seems to be effective, like more than just a static map. So if something dynamic and they can sort of see themselves in the event, then it seems to make a bigger impact on how they might prepare for the tsunami. As an engineer, we also look for other options. For example, some of the options are structural, that if there's not enough time to evacuate, maybe the building that they're in can serve for evacuation. So we learned from the Japanese that there's other options, including just going up to the top of a building. And so we've explored that option, and doing a lot of research on some of the other mitigation efforts. And then maybe third area is looking at the community as a whole, and what are some of the thinking that the community can have around critical infrastructure, so their water, power, transportation, And similar to the coastal erosion problem, if this communities start to expand, where's the best place to put some of the critical infrastructure? So hospitals, schools, this type of thing.
Yeah, okay, so, well, in fact, this is a very sensitive subject for us. And I don't know, Carlos, if you have knowledge about what is the work that we are doing here in Portugal concerning the tsunami impact, or if any, or not.
Well,
I know that I think that we have, well, in the Atlantic, we have an alarm system.
I'm not completely aware of what
Yeah.
we are doing. I know that there are people working on that because I crossed with some manuscripts, some scientific papers related with that, but I'm not knowing exactly who is working with that topic. Well, from the talk of Daniel yesterday, I took several ideas from our work because, well, coastal erosion and the tsunami are not exactly the same hazard, but some of the approach that we can apply to evaluate, well, for instance, the social behavior are important for us. And so it was a very good talk yesterday for us because we'll get some ideas and we'll try to explore that in the near future. Because when we are trying to predict the future, for instance, the next 40 years, we need not only to predict the physical behavior and so the shoreline evolution depending on the intervention that we do or not to do, or locate, protect or nourish, for instance, because all of them they have positive and negative things, and so to define what's the best option is very difficult, and it depends on the time horizon that we are looking at. But then there are the social prediction, because if we protect one area, maybe they will increase construction there because they think they are safe, or maybe they will move to another beach because that one is so artificial that they don't like. How the people will behave over that intervention or not intervention, and so we need to think about that, even if it is a tsunami or coastal erosion or other flooding in the coastal area for overtopping during a storm, for instance.
Okay. Yeah. So I think that probably some people that aim to study this or are studying these subjects, or civil engineering, or physics also, in geology department, and this could be interesting for them. And my question was, for becoming a researcher on coastal engineering, or to be an expert, well, if you want to work at the lab or at the consultancy, what are the subjects more important to know for this? We know that, but it's important to speak, namely to the students. What's really important to know maths or physics and modeling, and
I would say what I tell my students most important is curiosity.
okay.
You have to be curious because the coast is complicated.
Mm-hmm.
And I think you can really study it from any point of view, but just recognize you only have one point of view, and we need lots of points of view coming in. So we can come in with an expertise in engineering or oceanography, but we have to value the expertise from the economists, social scientists, even an artist, an historian. We have to bring all of the perspectives in, and I think that's what I value the most. If there's to want to be in this field, this coastal engineering research, I think a willingness to bring in all of these perspectives. I think that's most important, and that curiosity of how does the system work and what are some of the issues, and trying to understand the different types of solutions that are available. I think as an engineer, that's, you know, I'm always trying to look at these different options, but again, it's pretty fascinating, and so for me, curiosity is most important.
Yeah.
I completely agree with you. I think this area of work is very complex and crosses several different areas, as you said. And well, I think here the Aveiro University is a very good example of what we have in this kind of studies and areas. I think we have a good work done because we have easy way to cooperate with these all different areas: civil engineering, physics department, with the processes, earth science department, considering the surveying, understanding the materials in the bottom of the sea or how the morphodynamics changes, environmental department, planning, also social sciences. So coastal engineering should be aware about all these topics. So it's a very challenging area, and
I think the other thing I really like too is it's global. That I think you asked me early on, why was I interested in this aspect of engineering? Because you look at the planet, it's blue everywhere. And so I think that idea that this is a global issue, climate change is global, sea level rise is global, but the population, if you look on a global map, we're mostly on the coast. So I think that's the other thing I really like, and I think we can continue this international collaboration because of this global topic.
Yeah, that's true.
yeah, I agree with that.
Okay, so thank you a lot for being here and answering these questions, and also people that are participating. We also thank the support of the U.S. Embassy in Lisbon, and thank you all for coming.
Thank you.